Hello everyone, in this lesson we are going to learn about arrays. By the end of the lesson, you will learn how to create an index n-dimensional arrays in R. If you want to create an array in R, you simply use the array function. And you should take note of the following 2 points. An example of one-dimensional array is a vector in R, but there is a caution. So when we get to R, I will definitely demonstrate what it means to be cautious about calling vectors 1D arrays, even though they are very much similar. And also, a two-dimensional array is a matrix. So let's go to R and demonstrate how to create arrays. We've already learned about matrices. Matrices are two-dimensional arrays arranged in rows and columns. If you recall the very lesson on matrices, we even define it as a rectangular array of numbers arranged in rows and columns. But arrays in itself are n-dimensional or multi-dimensional. So meaning you can create more than just 2 dimensions of an array. Okay, let's go ahead and create a matrix called A. And we are going to demonstrate this very soon. So let's have some arbitrary set of numbers. So let me just go ahead and have 9 numbers to create a 3 by 3 matrix. So we do have 3, 3, and 3. So that is 9. The number of rows should be 3. So in which case, let's go ahead and execute this code. We are going to print A matrix into the console, and we have it here. Now, most importantly, we can check the type of data structure that this matrix belongs using the class function. We came across this class function when we were dealing with data types in R from one of our previous lessons. So class function is used to check the data type or the data structure of an object. So here we just simply put in the matrix A, which we have created. And if we should execute, you realize that it is a matrix and an array. So very importantly, we have already come across arrays when we're dealing with matrices. And so for that matter, because we said this is simply two-dimensional array, if we check the dimension of matrix A, then we end up getting 3, 3. So there are 2 numbers that are returned for the dimension. The first one representing the rows and the second one representing the columns. This is what we mean by two-dimensional array because it has 2 dimensions, the rows and the columns. So at this point, let's go ahead and learn how to create arrays in R. So if you want to check the documentation on this array function, you can seek help on R by simply typing the question mark symbol followed by the array function, the name itself, and just simply execute, and that documentation appears. So you can go through, we have multi-way arrays, and then we have a description and the usage. Very importantly, we are simply looking at usage. So this is the array function, and these are the arguments that we can pass in there. When we were studying matrices, we learned about the dim names argument. Now, this also applies to arrays, even though we are not going to go to that extent by assigning row names or column names using the dim names argument. But try as much as possible to go to the video on matrices where we actually applied the dim names, and you will be able to also apply it to arrays. So we are just simply going to stick to these 2 arguments, the data argument and the dimension argument. What happens is we just simply need to supply the data. So what am I going to do? I will just simply write array function and let's put in some data. Remember that the default value here, data, is NA. So if you should execute this, you are simply going to get NA, which is an example of a one-dimensional array. But we are going to actually pass into it our own vector of value. So let's have numbers like 3, 12, 8, 9. And now let's go ahead and execute. So let me just now minimize this window and execute. So we have 3, 12, 8, 9. Does this look familiar? Yes. We learned about vectors before. So this is simply looking like vectors. That is a word of caution that I mentioned before. So I want us to create a vector of these same numbers and actually show you something. So let's say we have X here. Actually, let me create it in the script so you can have access to it. So we would create a vector. It is a comment. And now let's have X object. So I'm naming it as X, and I'm going to pass the same values, 3, 12, 8, and 9. So if I execute and I print the X, you can see that they look very, very similar. But if you check the class of X, so what is the type of this particular X object that you have created? It is numeric. It is a data type like we had before. Okay, what about if I save this array as Y object, like this, execute, and then we go ahead and check the class of Y, that is an array. So there's a difference between what we produce as a result of a vector and what we produce as a result of an array. So you just need to take that caution like we mentioned in the slide. So even though a vector is seemingly one-dimensional array, you would want the object to retain its array nature by simply using the array function to create it instead of just simply creating a vector. So that is the difference I wanted to show you right here. Let me bring it up here. One more thing that we need to look at is when we actually printed the array, you would observe that the second argument, which is the dim, which is the dimension, says the length of data. So it means that the dimension by default equals the number of elements in the vector which you pass to the data argument. That is what they mean by length of data. So it means that this array, so let me just simply put it here. So this means that this dim is simply equal to 4. So let me just remove the name of the object and deal with the array the way it is right here. So in the end, let me copy this and paste it here so you can follow through with what I'm doing. So we have the code and we have the next argument, which is the dimension. And if we should execute the first one and the second, you realize that they produce the same result. So they are just simply the same. But what happens if I actually reduce the dimension here or increase it by some number? So let's copy this code and paste it here. So in that case, let's start with the number 1. So what happens? If we execute this, you are just simply trying to say that the length of this array is only 1. Therefore, you pass 4 numbers to the data, it will only return the very first number. So the dimension is just 1, the length of data is just 1. So it will ignore the remaining 3. If we proceed to change the number to, let's say, 2, then guess it, we have the first 2 numbers returned. And if we change it to, let's say, 6, and we execute, then it recycles over. So we have 3, 12, 8, 9, 3, 12, 8, 9. Then it starts all over again, 3, 12, then 3, 12 to make 6 as the length of the data. So that is how you can create an array. And by default, if you are creating a one-dimensional array, that is exactly how we do it. So let me just pass a comment right here, create 1D array. Now we will move on to the next point where we create a 2D array, which is just simply like a matrix. So what do we have to do? Let's create our matrix. Let's call it A, and I would now use the array function. So I would say data equals, let me pass some numbers. So 12, 9, 0, 5. And then the dimension, instead of actually specifying 1 number, you now need to specify 2 numbers, so you need to combine them. So we also supply a vector to the dim argument. So in which case, I can now go ahead and say 2, 2. So instead of just 1 number, which represents a one-dimensional array, 1 dim, I can now specify 2 numbers, which represent 2-dimensional array. So if I execute this and print A, then you notice that we actually get a matrix, 2-dimensional array. And yes, if we should check the class of A, that is also matrix array. So 2-dimensional arrays are just simply matrices. One more thing is that when you create an array, you can index it the way we actually dealt with it when we dealt with vectors. So for example, just like this x, if I wanted to call the very first number, I would say x and then square bracket. So let me just do that here. X is this one. So x square bracket 1, that calls out the very first number. But we created an array and stored into y. So y is this one here. If I also do the same, we also get the same result. So you can index it the way you index a vector. And when it comes to the two-dimensional array, we can index it the way we dealt with the matrices. So in case I wanted to call out the number 9, I would proceed to say A, then square bracket, and I'll put in two numbers. The first one representing the row, and 9 is found on the second row, so 2, comma, and it is found on the first column, so 1. So we have A square bracket 2, comma 1, and if you should execute, you get the result to be 9. So you can also apply your accessing of rows and columns matrices video lesson that we had also to an array. So in this case, what about the dimension of this array that we created? Also 2, 2, just like we did with matrices before. Now again, I'm going to take the same codes. Let's copy this and paste right here. And I'm only going to change the name of the matrix to B. So let's change them to B. But I just want to change the nature of the dimension. So here, let me go ahead and add some other set of numbers. So let's say 6 and 10. And in that case, there are 6 elements. So I can now say dim equals 3, 2. We combine them and we end up creating a two-dimensional array with dimension of 3 by 2. So if we should execute B and print it to the console, we end up getting this result. So 3 by 2 matrix. The class of B is going to be matrix array. And the dimension is 3, 2, where 3 represents the number of rows and 2 represents the number of columns. Let's go ahead and create 3D arrays. We begin with the array function and we specify our data argument. So let's give it a vector of 4 values. So let's say 4, -1, 8, and -10. And then with the dim argument, instead of passing one number or two numbers, we pass 3 numbers because we are creating 3D array. So we should have 2, 2, 3. And I'm going to explain very soon. This is getting more complicated, but don't worry, you will understand. So if I should execute this, we actually get something very different from what we have seen before. This is entirely new. What happens? Now, you would observe that we do have a matrix, and it's actually the same matrix right here repeating itself. But then we have 1, so just that the only thing we are seeing is comma, 1. We have comma, 2, and comma, 3. So you know what is happening? If you come to the dimension, the first 2 numbers create a matrix of that dimension. So there is a matrix of dimension 2 by 2, and that matrix is repeated 3 times. That is all. Very simple. So we have a 2 by 2 matrix repeated 3 times. And that's exactly what we are seeing. 2 by 2 matrix with these numbers repeated how many times? 3. And that is what this 3D array looks like. And if I should save this into, say, Z, and I actually check the class of Z, we know that that is, not found because I have not executed when I actually named it as an object. So let's run it and now check the class of Z, and that is an array. And then if we should check the dimension of Z, we end up getting 2, 2, 3. That is exactly what we specified in the dim argument. So 2 for the number of rows of the matrix, 2 for the number of columns of the matrix, and 3 by how many times this 2 by 2 matrix should be arranged. So you know what is going to happen? If we print this Z, and let's say you actually wanted to call out the very first matrix here, then it's very simple. Just use the name of the array Z, followed by the square bracket, and put in comma, 1. That calls out this entire matrix. But the matrix here and that of this one are the same. So why don't we use different set of numbers? In that case, we should have 12 numbers. Okay, so it's very simple. Let's go ahead and do that. So let me just simply copy this same code. And now let's break this one down. Okay, let's create everything quite new. So let's call this one G. We are creating an array G, and we have array function. Let's break it. And let's have our data equals a vector of, now let's pass our vector. So let's break the vector as well. Then after the vector, we will now specify the dim argument, and that is also going to be 2, 2, 3. But this time we should have 12 numbers. So I am going to copy these numbers to be for my first 2 by 2 matrix, comma, and let's have 10, 100, 1000, and 10,000 for my second matrix, and let's have 1, 2, 3, and 4 for the third matrix. Now let's go ahead and execute this code, and then we should print the G array, and this is what we get. So when we print the G array, we can now have our different set of numbers, 12 numbers populating each 2 by 2 matrix arranged 3 times. Okay, so once we have this, let's say we wanted to call out the very first matrix, then I would have to specify the name of the array. Why don't I do that in the script? That is wonderful, so you can have access. So in this case, you would write the name of the array followed by the square bracket, and then you would say comma, comma 1, because that is how it names the very first matrix. So comma, comma 1. And if you should execute, you would see that that is the result you get, the very first matrix. If you also go ahead and say G, comma, comma 2, and execute, you will also get the very second matrix, which is this one. And for the third matrix, you can also have the name of the array, comma, comma 3, and you will get the very result. Now, why comma, comma 1? That is because if you now need to actually access any number or element within that matrix, you can do that before this first comma and the second comma. So before this first comma, you have the row of the matrix, and before the second comma, you have the column. So let's say that from the second matrix in the 3-dimensional array, I want to call out the number 1000, which means this number 1000 is found in the first row and second column. So what do? All I have to do at this point is, first of all, let's copy this and paste here. So that means we are accessing the second matrix within the 3-dimensional array. Now that we have this one, because we want to call out the number 1000, which is found in the first row, then before the very first comma, you put in 1 to represent the first row, and then it is found in the second column. So here too, you put in the value 2. So you have first row, second column from the second matrix. And if you should execute, we get the number 1000. So you can see that for a 3-dimensional array, you have to pass in 3 numbers for the dimension. But in matrices, you only needed just 2. And for vectors, you needed only just 1. So that is how you get to differentiate these data structures that we have been working with so far. You would ask yourself, why is it important that we have to do this? Actually, there is a data set. Okay, so one day we will be learning about data frames very soon. There is a data set in R which is called Titanic. So I will just simply type Titanic. Just type that. That's all, because it's built into R. So you don't need to install anything. Just write it out and run. When you do that, you can see, what do you see? A 3-dimensional array. All right, why don't we check the class of Titanic? So class of Titanic, a table. That is very surprising though. But yes, it looks like an array. So this is a table, but at the same time, I would consider it an array because that's exactly what we saw. So it is a 3D array, a 3-dimensional array, and each one of these is a matrix. Each one of these is a matrix. So you can be calling them out if you wanted, like we did with the G array. So sometimes you will be coming across some of these forms of data and you would know how to do it. That is why it was essential we go through all of these data structures. This is where we could have brought this to an end, but I think there is more things that I want to show you if you want to continue. So at this point, let's go ahead and print the G array. And so if you also wanted to call out the same number 1000, you could have done it in another way. Instead of doing it this way, you could maintain the comma, comma 2, which would retain that matrix. And because this is now a matrix, you can also index or call out or access that number using the lessons that we have learned before, how to access rows and columns from a matrix or the elements from a matrix. So how do we do that? Right after extracting the very second matrix, I can open another set of square bracket, and in there I will specify the row and column. It is found in the first row, second column. So I would say 1, 2. And if I should execute, you end up getting the result as 1000, just like we actually had here. So that is how you can also index an array or call out elements from within an array. Well, I think I would like to just simply show off and go ahead and create a 4D array, but that is how far we can actually go. From the very beginning of my studies into R, people found it very difficult, and most people actually tend to avoid it, or at best they would teach up to the second, the two-dimensional array. But here I would just want to extend it further so you understand really how to deal with arrays, even though you might possibly never come across a 4D array, but like Titanic, you would come across a 3D array-like tables, and you will be able to handle them. But I just want to show off and show you the complex things that you can do with R once you have a skill. So let's create a matrix called F. Now, you can see that this F is colored differently from all the variables that we have created. And that is because this F is a reserved keyword in R. For example, remember the logical constant false. If you type the uppercase letter F and execute, it is the same false. So when we were creating matrices, you remember there was an argument where we said by row equals true. You could have actually have said by row equals T, and that would also work because T and true, they're actually the same reserved keywords for the logical constant true. So that is why we have it here. It is not really advisable for you to be using any reserved keyword to be naming objects that you create in R. So for the purpose of this demonstration, let's just simply change it to say H, and let's create our array. So we have this array, and what I'm going to do right now is, actually let's make it very simple. So I would say data equals 4, -1, 8, and 10. And then let's set the dimension to be, guess it, 2, 2, 3, 2. Wow, that is very complex, but yes, it's very simple. So what is going to happen? The first two numbers would represent the matrix dimension of this data. So we are going to have these numbers arranged in 2 rows and 2 columns. That's going to be the dimension. Now, that should have repeated itself 3 times, but because we have another number for the 4D, the 2 by 2 matrix will be arranged 3 by 2 times. The same way. So the 2 by 2 matrix will be arranged also in a 3 by 2 matrix form, like something like that. Okay, I believe you get the idea. So let's execute this code. Let's check the class of H. It is an array. Let's check the dimension of H, 2, 2, 3, 2. But then if we should print the H, surprise, surprise, very complex. We have 2 by 2 matrix arranged in 3 by 2 ways, and those 3 by 2 ways we have 1, 1, 2, 1, 3, 1, then 1, 2, 2, 2, 3, 2, arranged in 3 by 2 ways. So it is more or less like you do with matrix. So this is like a matrix found in the first row, first column. Think of it like that. Another matrix found in the second row, first column. Another matrix found in the third row, first column, in that order. Another matrix found in the second row, second column, in that very order. That is how it is represented. So because we are using these numbers in a vector, we actually get a repetition of these matrices. So in a way, we just simply need to count how many matrices we have here. So we have 1, 2, 3, 4, 5, and 6. So which means 4 times 6 is 24. So if you wanted to populate each of these matrices by your own numbers, then you simply need to supply 24 numbers to create this 4-dimensional array. So let's go ahead and do one crazy thing. Excuse me for the language. So let's create an array V, and data equals my vector, and I'm going to pass, so let's say 777, 777, and this number. Let's have 100, 200, 300, and 400. Let's have 1, 1, 1, 1, and then 9, 9, 9, 9, 10, 10, 10, 10. And I think that should be it. So in which case, we are going to have, so let's specify the dimension. So dimension is going to be 2, 2, 3, and 2. So that should be 20 elements. Actually, not 24, 20 elements. So if we should run this V and print it to the console, we end up getting each one of them. I think there is a recycling because I do see this here and this here. So it was left with another set of 4 numbers. So let's go ahead and do 3, 3, 3, 3. Actually 24 elements. It's hard to keep count of some of these things, but yes, it's all part of the coding. So here we run it, and then we can go ahead and print the V, and in which case we now have our 2x2 matrix arranged in 3x2 ways. So imagine that if you wanted to call out, let's say, this very matrix, then it's very easy. V array, then followed by the square bracket. Then you would have to supply everything that you see here, naming that particular matrix. So in here, you would have comma, comma, 2, comma, 2, and that will call out that matrix. So let me copy this and paste it in the script. And so once this one calls out that matrix, if you wanted to call out, so let's actually call out this one because that has different set of numbers. I wanted to show you how to extract a particular element from this matrix. And so let's call out this matrix. So I just simply need to change this one to 1. And I execute. So we have 100, 300, 200, and 400. And if I wanted to call out the element 200, then that means that is found in the second row and the first column. So I can do it in 2 ways. I would say V, then square bracket, then second row, first column, 2, 1. And if I should execute, we have the 200. Or you could have gone ahead and call out the matrix this way, then follow it with another square bracket and call out this element 200. So that would be 2, 1. So in the second row and the first column. And if you execute, you end up getting the 200. So this is how you create arrays. At this point, I will leave you here and you can demonstrate your coding skills by extending it to 5D arrays and know how that looks like.